So this is the seventh and final installment of the quadratic and linear equations test for maths methods 2018. This last page deals with the linear work that was covered in chapters 2 and indeed 1. First question is about equations of lines and parallel and perpendicular lines. So that's 2C, 2D, 2E for equations of lines and concepts of parallel and perpendicular. First one is find the equation of the line that goes through the point 1, 6. So you're given a point, and it's also parallel. So parallel to y equals 3x plus 4. Well, what we know about parallel lines is that their gradients are equal. And we also know from our equation of a line formula, which is y equals mx plus c, that in this case the 3 is the gradient. So we have 0.16 and we have gradient equals 3. Now 0.16 we would call x1, y1, and we're going to put it into the formula for the equation of a line, which is y minus y1 equals mx minus x1. We use this formula, this particular formula, if we're given a point and we're given a gradient. And in this case, indeed, we are given a point and a gradient. So now we sub in y minus 6, that's the y1, equals 3 times x minus 1, the gradient in the x1. Y minus 6 equals 3x take 3. And traditionally, or usually, we put the 3x, the minus the 3, and the plus 6 all on that side. Y equals 3x plus 3. That would be the equation. For part B, we're asked for the equation of the line that is parallel to the x-axis, still going through the point 1, 6. If it's parallel to the x-axis, it's going to look like this. It goes to the point 1, 6, which is there, 1, 6, but it's parallel to there's the y-axis and there's the x-axis. So you can see there's parallel to the x-axis. So it's a horizontal line that goes through y equals 6. In fact, its equation is simply y equals 6. And it's finished. Y equals 6. And part C, what about if it's perpendicular to the line with equation 3x, y equals 3x minus 4? Now we know about perpendicular lines that their gradients are related by that formula. M1, M2 equals negative 1, or M1 equals negative 1 on M2. They are negative reciprocal of one another. You flip it over and make it negative. So the point we know is 1 and 6, and the gradient, well, the gradient for the line we want now won't be 3, it will be negative 1 on 3. Negative 1 on 3, and we sub them into the formula. Y minus y1 equals mx minus x1, because we've got point x1, y1, and gradient m. So y minus 6 equals negative a third x minus 1. Y equals negative a third x plus a third, minus a third times minus 1, plus 6. Y equals negative x on 3 plus 6 and a third. That could be written as y equals negative x on 3 plus 19 on 3. Could even be written as y equals negative x plus 19 all on 3. There's a range of ways. The other thing you can do is multiply the whole thing through by 3 and get 3y equals negative x plus 19. And then we might put all that on the one side. 3y plus x minus 19 equals 0. So that and that and that are all ways of writing that final equation. So that first section of work was about parallel and perpendicular lines and also equations of lines. How would we mark it? We would give 1 mark for subbing correctly into the equation of a line formula, and 1 mark for getting the final answer, and 1 mark for knowing about the horizontal line through y equals 6, and 1 mark for correctly identifying the perpendicular gradient, and finally 1 mark for getting one of these equations down here. It sort of doesn't matter which format it's in. Perhaps that one there, negative x on 3 plus 9n on 3, looks nice and neat. That's okay as well. Doesn't really matter. There's your 5 marks. Last question is some linear equation work. We've got to solve. We've got to get x by itself to solve this. I'm not going to multiply both sides by 4 or by 3. I'm going to multiply by, the highest common multiple of 4 and 3. Or lowest common multiple of 4 and 3, which is 12. So I'm going to multiply both sides by 12. That will have the effect of getting the 4 and 3 up to the top. So I'm going to have 12 times x minus 3 on 4 and 12 times 2 minus x on 3, and that equals 12 times 5. And then so what happens here is that becomes a 3, and so I get 3x minus 3, and this becomes a 4, and I get 4 times 2 minus x equals 60, 5 twelfths. So I get 3x take 9 and 8 minus 4x equals 60. 3x minus 4x is negative x equals 60 plus 9 minus 8. Negative x equals 61, I think. So then I divide the negative over x equals negative 61. X equals negative 61. That's the answer to that first one. X equals negative 61. This is an inequality, so we need to be a bit careful. We sort of treat it like an equality, but then when we muck around with that inequality sign, we've got to be careful. So 1 minus 3x greater than or equal to minus 4. First thing I do is multiply the 2 over. You're allowed to multiply both sides by 2. Doesn't change anything. Both sides by 2. This is what we did to begin with. I could subtract that 1 over. Negative 3x greater than or equal to negative 4. Take 1. Negative 3x greater than or equal to negative 5. And now comes the trick. If you divide by a negative number, divide or multiply by a negative number, you swap the signs. I'm going to take the negative 3 over, so I'm actually going to swap the sign, negative 5 on negative 3. If I divide or multiply by a negative, this leads on to reverse the inequality. Probably pretty important. X is less than or equal to 5 on 3 is the final answer there. X less than or equal to 5 on 3. How would I mark this last 2 questions, 16 and 17? 16 is worth 2. Well, in which case you're going to sort of get 1 for all this, getting rid of the 4 and 3 on the bottom and simplifying, and then 1 for the negative 61. And down here, this inequality is worth 3. So I'll probably get 1 for unraveling some of it, 1 for changing the sign, and 1 for the final simplified answer. That concludes all the solutions to the Maths Methods Test 1 on quadratic and linear equations. Should you need any extra help with this last page, you would look at the work from 2ECD, the equation of line stuff, and you'd also look at the work from 1A. So that's it. Thank you.